Hello, everyone. Welcome to Python Challenge for All. Okay, so today we will kind of do um, numerical computation, how to solve an equation iteratively by numerical computation. Okay, lesson 67. So today's topic is how to solve x squared minus 5 equals 0. Actually, if, as you know, this will give you plus minus square root of 5, which we want to find which we will want to approximate numerically. So how to solve it? First, maybe we need to visualize a graph by plotting as we learned in the previous lesson. Okay, so let's copy this part, take it down to a new box. Okay. And maybe we can call this today's topic as bisection method. Okay, so what we want is, as I said, x squared minus 5, which is exactly the same as this. So let's take a look at the graph again. So we want to find this place. Or maybe we can limit to 0 to 5 to see how it looks like. And I don't need x-axis actually. So if we run it, it will be like this. We want to find the x value at this point, okay, 2 point something. So how can we do that? So today I will tell you the method called bisection method. This is applicable when the signs of the function differ. So we will start as low value of 0 and high value of 5. So let's do this. And also, we need to define the tolerance as 10 to the minus 5. Okay? So let's start. What we want is, so x low, x high. Yeah, we already have it. So next thing is we want tolerance as delta 10 to the power of negative 5. Okay. So what we want is we want to keep a list of error values. So we will have empty list. And then we will see that low high equals, say, 0 and 5. Okay? And then bisection method is iterative process. The functions evaluated at xr, and next subinterval is determined to be the half of it by replacing either x low or x high. Okay? So it's might be confusing, but I hope you will learn about it. If there's a graph like this, okay, let me use the pen. Oh, I can't draw it. So maybe just follow me by for, say, n in the maximum repetition is maybe 100. That's enough. Okay. And x is the midpoint of low and high. So low plus high divided by 2. And we will compute the y value for that point. And let's print the cycle n, x, and y. And at the same time, let's print the size of the interval as high minus low. Okay? And then we'll add the y value to Rix. We want this y to be as close as possible to 0. Okay? So if absolute value of y is less than delta, then we will break. Otherwise, if y is larger than 0, then we'll use use x as the next, sorry. We will use x as the high value. Else, use x as the next low value. This might seem confusing, so please take a look at why this works. Okay? Each time, if the intersection point is above, let's draw a very simple graph. Okay, so this is how it starts. Okay, there's a graph, and we start from high point as here and low point and here. We'll check the midpoint m, which is half of L plus h divided by 2. Okay, if this f of m is less than 0, we will next low, okay? And repeat the process. Okay? Okay. If the middle point, f of m, is if less greater than 0, then we will change m as h2 and repeat the process. This is how the iteration goes until the f of m, f of x, is less than delta. Okay, this is how the process works. Okay, let's go back to the slide and see. Let's run the code. By doing this, we have the list of sequence, okay, loop 0, loop 1, and each time the interval is halved. And this is the x value, and this is the y value, which is f of x. And when the interval is less than the delta tolerance, this value should be small enough. This is actually this. This is actually when y value is less than delta, it stops, and this should be the answer. Okay, let's take a look. If you square this number, it should be very close to 5. Okay, this is just a error of tolerance. Okay, this is how the bisection method works. Okay, please try yourself to see how this works. And we will try another method next time and compare the speed. and have a discussion about the convergence. Okay, so please be sure to come back. See you next time. Bye-bye.